Hey, good morning everybody. Welcome to your course on Java Object-Oriented Programming. Before we get started, I wanted to mention that we're not going to start from the complete beginning of Java, so if you need any additional help, well, there's some resources out there. One, I have a Java series on YouTube, and I have this course on O'Reilly Object-Oriented Programming with Java, and I'm not sharing this because I make a ton of money. No, unfortunately. I'm sharing this because it's a great resource, and I think you can get started with a free trial and just watch it. So this is going to go in a ton more detail than what we're going to talk about in these videos, because these videos are really just designed to get to the point and really not go into a terrible amount of detail. I mean, it's not going to be nothing, but at the same time, I'm not going to overwhelm you with a bunch of stuff. So what we're going to do is we're just going to learn the basics of getting started with object-oriented programming. So I'm already really assuming you know how to make a project in whatever editor you're using. It doesn't really matter whatever editor you're using, as long as you can run the Java program. So I have this project here. We will just right click, new class. I assume you guys know how to create a project and like the bare basics of Java. We'll just call this OOP and public static void main. This is where our main method is going to be. And there we go. So let's just, make sure everything's working. We'll say, Claire, you're emailing me at 2 in the morning. Are you serious? So let's just try saying hello world and run this. And we get hello world. All right, so we got a working application and we can just talk about some of the different components in here. So everything is defined within a class. And inside of this class, we have what's known as a method. This is a static method. We might talk about that soon, but basically, this method gets ran immediately when our application launches. And inside of this method, we are invoking another method, println. And this here that we're passing in is known as an argument. So anytime we're passing in data, it's an argument. A parameter, although these terms are often used interchangeably, is slightly different. And that is when you define a method, you can define a variable to take this information. So someone wrote this println method to take one parameter. And we might be able to right click and go to definition or something. So open declaration. And here is the definition for it. So it takes one string called x, and they refer to that string throughout this method by the name x. Let's back up just a little bit and talk a little bit about this out here. So we can right click open declaration. And this is a static variable. Again, that static word comes up. And basically, static means you don't have to create an instance of the class. So we'll talk about that when we create our own class, but that is just the basics. So to see how that works, we're going to create our own class now. So let's go ahead and X out of these documents there. And what we're going to do is we're going to basically talk about how to create an instance of a class. Now, when you create an instance of a class, it's known as an object. And if you're new to this, I'm throwing out a ton of words. Anytime you hear a new word, I want you to write it down because you're going to need a vocabulary list by the end of this series if you're new. So we're going to create an object, which is an instance of a class. And here's how that's going to look. You say what type it is. And the whole point of object-oriented programming is so that we can create custom types. So a user is very specific. It's not like a string or an integer. It's something specific to our application. We're going to create an application to store users. So we say what type it is, then we give that variable a name. This is no different than if we did something like int x. Instead of saying int, we're saying user, and instead of saying x, we're saying you. Or, you could put Caleb or something, but we'll just go with a general name here, such as you. And then the way you create the object is you say new, and then the type again, user, and then parentheses. So we're going to get some errors, and I'm going to talk about how to fix those in a second, but anytime you do this, you're creating an object, and that object is stored in this variable u. Now, when you say new behind something that looks like a method, well, this is known as a constructor. We're invoking the default constructor for this user class. Again, a lot of words. We'll understand all those by the end of this. So when we do this, this is going to give us a new user object, and that's what we're assigning to you. So now we need to create this user class, so we can hover over user and say create class user. If you're not using Eclipse, it might be a little bit different, but you can also just manually create the file as long as everything matches up. So everything looks good. We'll just hit finish, and we have this class user. And what that's going to do is it's automatically going to get rid of that error. So we should be able to save, and we should be able to run. Now our application doesn't do a whole lot more. However, it's working, so that's progress, right? And now that we got pretty much our structure we're going to be using, I'm going to be minimizing this package explorer. All right, so we created a user. That's it. That's how you instantiate a class into an object. We're done. But honestly, this isn't really that useful. Like, what do we do with this user? Well, that's where attributes come in. You know, we can associate different variables with the objects. So let's go into our class, and here's where we define the things we want to store about each user. So what we do is we just give it a type and then a name, just like creating any other variable. So we'll go ahead and say string, and we'll give this person a name, and then we'll say string, and let's say this is for a website, you know, maybe you have a subscription, we'll say string membership. And now what we can do is we can assign values to these two variables. So I'll do that over in our main method. So we'll say u dot, and you can see these pop up right here. So it's a string membership and a string name. So let's give this person a name, and we'll set that equal to Caleb. There we go. And then we'll say u dot, and this time we'll go with membership. And obviously, guys, I'm gonna have the gold membership, and there we go. So at this point, you might be wondering, like, is this really that helpful? Do we need to create this user object and just to create variables? Well, right now it doesn't seem that useful, but as we get more and more stuff describing a user, well, it's nice to just keep things organized. And this basically allows us to create code that matches the domain requirements or the business requirements of the application more specifically. So the code is much more friendly when we are developing. Instead of just having a bunch of variables thrown out everywhere or a bunch of arrays, we can make it specific to the problems we're trying to solve. So objects basically describe real world things, and it's so much more helpful. It's a better way to design our software. Now there's a lot of different other ways to design software and a lot of different arguments, so I'm not saying this is the only way to do it, but it is important to know. Now the benefit here is since we created that user class, we can basically use it as a template. And that's what I want you to think of the class. I want you to think of it as a cookie cutter that you can use to make a bunch of cookies. You don't actually really use the class itself very often unless you have static stuff in there, which again, like static, you don't have to do this part of it. You don't have to instantiate here. But you can think of that cookie cutter as something, if you're making cookies, you know, you're not going to eat that cookie cutter. You're going to use it to create new cookies that you're going to then eat. So the same thing applies in programming. You're not going to be using that cookie cutter a whole lot. You're not going to be using that class a whole lot, but more than likely you'll be creating objects and using those objects. And the great thing here is that we can use that user class to create multiple users. So for example, we could say user u2 and create a new user. And for this one, we can give a different name, and we can give it a different membership. There we go. So how do we actually access these values? Well, let's just go ahead and print something. So we will say u.name, and then we'll do the same thing for the other one. So we'll say system, and this one will get u2.name. So that is how you access those elements. You use the dot operator on the object. So when we run this, we should get the hello world that we created up here, and then we get Sally and null. And you can see I made a really dumb mistake because this is why I probably shouldn't make videos at 2:30 a.m. But no more mistakes from this point on, but those things happen. So let's try this again. We'll run this. And now we got Caleb and Sally. So that's another important thing when we are working with objects. If you don't assign a value to those attributes, they are null. Unless, of course, you're using something such as an integer. Let me just go through a really simple example just to show. If we had the age of the person here, and let's just say we printed u.age, that will default to 0. So strings and any reference types like other objects are going to be null. The primitives are going to have a default value such as 0. So if you get much into programming, you're going to hear a lot about getters and setters and a concept known as encapsulation. Encapsulation is one of the big 3 pillars of object-oriented programming. Now, before we start a war in the comments section, although if you want to do that, that's fine, because that increases my engagement and stuff, but there's argument about how many pillars there are, but there's 3 really main ones that I see: encapsulation, inheritance, and polymorphism. So this is the second video in your object-oriented programming Java series. If you're just jumping in, welcome. We're going to be talking about encapsulation. And the idea behind encapsulation is that you can hide inner details. And why would you want to do this? Well, for one, it allows you to basically, and this is where that one of those other important words, abstraction, comes in. You can abstract away the insides of the class. So the person who's using the class, the person who's developing this code right here, they don't have to know all of those inner details defined in this class, which makes developing a whole lot easier. So what I want to do is I want to talk about encapsulation through the eyes of getters and setters. Now, these are methods or just functions attached to objects that allow us to gate access to our attributes. So right now we just have direct access to name, membership, and age. And I'm actually going to get rid of age from the last video. We don't need that. So what that means is we can assign values to these directly. Although that's not the end of the world, you might want a little bit more control about, what could be assigned or how that data is stored internally, and that is made possible through getters and setters. Getters and setters also allow us to have a consistent interface with working with objects. So, if we ended up changing some inner details of the class, the person who writes the code that uses that class doesn't necessarily have to change anything. And that's one of the values of using getters and setters. And if you come from other languages, from C# or Python, you may have heard of properties. Well, that's a similar thing, similar capability, but in Java, we're just going to use a get method and then a set method. So let's see what that looks like. So we'll go into the user class and we'll go ahead and just create a method to set data. So set methods are usually going to be void, which means they're not going to return anything. And then we'll just say set name, and this is going to take one argument, which is the name itself. So we'll say string name. And then what we'll do is say name is equal to name. Now let's take a look at this. If we hover over this, it says the assignment to variable has no effect. And this isn't going to work because we have a naming issue. It's kind of funny because the variable's named name. But anyways, we need to be a little bit more specific. So if we want to talk about this variable here, well, one thing we could do is we could just change the name. So you'll often see it like underscore name. And that way we know that this is something that is just for that class's use. And any time we want to talk about that attribute outside of there, then what we can do is we just use it without the underscore. And that is one way of doing it. Alternatively, if they have the same name, then you just need to prefix this with this. That'll work as well. So I'm actually kind of a fan of the underscore, just because I think it avoids any kind of confusion or risk. And it's pretty common convention that things starting with an underscore are known as something you're not supposed to be touching, but you can still access that. So over here, we can still access that name like so, underscore name, and that's going to work just fine. If you want to prevent access to this name, it's really simple. From the class, all you have to do is prefix this with private. This is known as an access modifier, and it modifies the access. So we basically just said, hey, we can only use underscore name inside of this class file. Anything outside of this is going to give us an error now. The field user underscore name is not visible. So that, I think, is the preferred way to do it. Basically, hide that backing field and then create a set method. So what about the get method? So this will allow us to get that value. So this one will return something, the actual type of whatever we're trying to get. So string, and this will be get name, and it's not going to take any arguments. Inside of here, all we do is return underscore name. So We'll use this to give it a value. We'll use this to get the value. So let's talk about how to use that real quick. Inside of our code, let's go ahead and just clean this up a little bit. We'll just work with one user for now so we're not distracted or mixing up variables or anything like that. So now we have one error here, and we have an error down here for u.name where we're trying to print it. So here are where those two methods are going to come up. If we want to set the name, we just say u.set_name, and then inside of parentheses is where that value is going to go. So we'll delete this over here and instead put it right here. So that's how you set the name, and then to get the name, all you would do is say u.getName, and then there you go. That's it. We should be able to run it. And boom, that's how you get the name. Oh no, I'm gonna sneeze. I guess not, we're good. So that is a getter and setter. It also allows you to customize the code. So if you want to do some processing when something is set or when something is gotten, then you can do that here. So for example, we could sys out logging to log file. I'm not actually going to log to a log file. That'd be way too much work. So let's go ahead and run our code now. And you can see that shows up in the log. So having that extra processing isn't something you can do with plain attributes. So definitely pretty handy if you need to do a little bit of extra stuff. And this is where that encapsulation thing comes in. You can basically hide this name and then do whatever you want to set that data or get that data. It's kind of like a cell wall. If you guys ever did biology in school, like it's like this thing around the cell that has different rules on what's allowed to enter the cell and what's allowed to exit the cell. Hey, welcome back everybody. This episode we're going to talk about method overloading. This is a really important concept because when we are working with a typed language like Java, we have these different data types string. So if we wanted to set this name using something else like a number or, an enum, well, it's not going to work. The compiler is going to catch that because of the typing conflict, and it's going to be like, no, bro, you can't do this. So that is where method overloading comes in. If you want to basically create different variations of methods with different types. So let's just get into that, and yeah, let's get started. But before we get started, and no, I'm not going to say this video is sponsored, although it is, and we'll talk about that in a second. I wanted to give an example of method overloading, which is println. So check this out. If I do a system.out.println, I can pass in a number here, and that works just fine. I can also pass in a string, and it works just fine. So what I want to do is I want to take a look at the declaration. Oh, geez. It's not working. Okay, there we go. And you can see this one takes an integer. What about this other one? So let's go up here and we'll check the declaration of this one. And you can see this one takes a string. So there's actually different variations of the same method, with the only difference it has a different signature, which is the fancy word to describe the entire structure here. However, the return type is not part of that signature. So the main thing is just the combination of the different parameters, the number of them, or the type of them. All right, so let's get back to this. What we're going to do is we're going to create another method here for set name. So we'll just say void set name. And in order for this to be an overload, we have to have a different number or type of parameters. So right now this is valid because this one has 1 parameter, this one has 0 parameters. So that could work, although there's a couple of issues with this, which is, why would we ever want to accept anything except a string? For a name, it makes sense that it's a string. However, for some methods, it does make a lot of sense to have different types that work with it. So an example of a good method that could use an overload is this membership here. Well, a membership, it could be a string, or, maybe it could be different number codes, 1, 2, or 3, depending on the different tier. Or maybe if you guys have worked with enums, it could be silver, bronze, or gold. So let's talk about doing that. So what we're going to do is we're going to basically copy this set get setup, but for membership. So then we will finish our encapsulation, and we'll also be able to create an overload. So let's first create the set membership. So we'll just copy that pattern, set membership. So it's going to be void and then set underscore and then whatever we're setting. And then the very first thing in this parameter list is going to be of the same type as this attribute here. So string membership. And then inside up here, we'll just change this to private and give it an underscore. So anytime we want to refer to that in this class, we'll just give it an underscore. Such as here, we will say underscore membership and set that equal to membership, which will be passed into the parameter here. So that should be the set. Now let's do the get. And if you need some more practice with getters and setters, that's what we did in the previous video. So be sure to check that out and also to click the like button. And now we'll just say string get membership. And this is going to not take any arguments passed in. And this will just return underscore membership. So let's just make sure we can use these getters and setters correctly in our calling code. So u.membership, instead of that, we're going to say u.setMembership and pass in the value gold. And then we'll also check the setter. So we'll say print line u.getMembership. Running this puppy, we got Caleb and gold, so it seems to be working. All right, so the getter and setter is working. Now let's create that overload. So we will create another set. So it's still going to be void set membership. And this one is going to take an enum value. And this is going to be a great opportunity to show you that you can store other different types inside of this main type here, class user. So that'll be pretty cool. Just follow along. And sorry, I don't know why my scrolling is so terribly slow. It's like glitching out on me. We'll just say membership. And then membership again, lowercase. So this is the type, and then this is the variable name, and then we'll just open this method. All right, so we need to create this type. If we hover over this, it says create class membership, although we don't actually want to create a class. We want to create an enum, which is just a little bit different. So it might be in here. Yep, there it is, create enum membership. So we'll click that, and then we'll hit finish. And here's where we can define the different options for this enum, bronze, silver, gold. So this isn't a separate file. I think we can put this in the same file. Now that I say that out loud, like I'm starting to like second guess myself. So let me just double check that. So we'll just paste that here, indent that, and save. And we shouldn't get any compiling errors or anything. It looks to be good. So for me, since the membership is directly associated to the user and that's all we're really going to be using it for, it makes sense to define that inside of the user class. So what I'm actually going to do is I'm just going to delete that generated file, which was the membership file. So we'll go in here and just right click, delete. Okay. Continue. All right, so let's talk about how to create an enum now. Bronze, silver, and gold. All right, that should work. And then what we can do is we can decide how to store this internally. So I'm going to just store it as the string version. So you could also store it as an enum. That's up to you. So here's how we can basically convert an enum value from this parameter to a string. All we would need to do is say underscore membership is equal to membership, which refers to the parameter, dot name, and this returns the name of the enum constant, and this is a method. There we go. All right, so let's just test this out. Basically what we need to do is we need to invoke it using the enum variation and then see if when we get the membership it works exactly the same way. So here's what we're going to do. Sorry, we're going to change the membership here. First thing we need to do is we need to access that enum, which we're going to do through that class directly. So what we'll do is we will say user with a capital U dot and membership. And then on here we have some different options, bronze, gold, or silver. We will go with gold. Click that. And let's run this. And you can see we still get that value gold as a string. And it's fantastic. It's working. Yo, what's up everybody? In this episode, we're going to be talking about constructors. So it's a really important part of object-oriented programming because anytime we create a new object, we are invoking a constructor. We're going to talk about how they work, how it's different than just a normal method, and how to create variations of the constructor. So this right here is known as the default constructor. Anytime we create a class, the default constructor is automatically going to be there. We don't even have to type anything out. So that is why it's cool, you know? We don't got to do any extra work. There's nothing in this user class that shows a default constructor. So the problem is when we want to basically have some way of, let's say, passing in the name and the membership when we create the user, so everything is done at once. Well, how would that look? Well, it might look like this. Having an argument here, Caleb, comma, and then the membership, which again, because we did some method overloading in the previous episode, we could just use a string here, such as silver. And then we can just get rid of these two lines and make our code a whole lot cleaner. And you will see code like this a lot when you're programming. But you can see when we do this, it doesn't work. The constructor, user, string is undefined. So it's looking for a constructor that takes two strings, but it's not defined. So the easiest thing to do is just create the constructor, and it's just going to build out a method here. So a constructor is just a method, but there's one difference in that there is no return type. So you can see here it's just public user. Oh, and another thing is it has to match the class name exactly, but there's no return type like other methods where this one has void and this one has a string. You don't have to do that for constructors. So basically what we need to do now is we need to set the names to the different attributes. So go ahead and pause this video and set those attributes. All right, now that you're done setting those attributes, I'm hoping you did not do this. Underscore name is equal to, oh, and you might want to give these better names. Let's say name and membership. What I'm hoping you didn't do is underscore name is name and underscore membership is membership. And why would this be a problem? Well, honestly, it's not that big of a problem. Like, I'm not going to be like, oh, go back to first grade. But the problem here is that we're accessing these attributes directly. And even though we're in that class, it's really not smiled upon to do this access in numerous locations, because we basically need to always go through the getter and the setter. So the proper way to do this is to actually just invoke those methods. So we would say set name and pass in name, and then we would set the membership the same way. So set membership. And that should work the same way, but then if we went and changed some of that functionality, you know, we don't have to go and change that in numerous locations, possibly introducing bugs if we forget to do it somewhere. So this is the purest form of encapsulation. Awesome. So now we should be able to run our main code. Let's just check it out. We're still getting some issue. The constructor user is undefined. What? Okay, I just saved it and that error went away. I don't know. I swear. Eclipse is a little tipsy sometimes. So what we should be able to do now is we should be able to run our code and it should work exactly the same way. And it does. So when would you want to do this? Well, one, if you want to make the code easier to read, you can do it this way. So now, instead of having 3 lines, we only have 1 line. The other really important thing is that we can do this to require certain things when we create a user, which this is probably the better use, not just for clean code, but for proper code. For example, a user might not be valid without a name or a membership type. So if you don't want those half-created objects floating around in your code, then you can basically force that data to be required using a custom constructor. So that's the big thing, in my opinion, is you use constructors to force proper data. But what if you don't really care? You know, if people want to use the default constructor, that's fine. If they want to use the custom constructor, that's fine too. Well, you're going to run into an issue, because if you go down here and you try to create a new user, we'll just call it U2, and then say, not like the band, guys, like just a second user. Well, now we're getting an error. What used to work is now broken. The constructor user without anything is undefined. What the fudge? We need to fix this. So the reason that happens is because of that previous thing I mentioned about if you want to force data to be passed in, well, then we don't want people to be able to use that default constructor. So if you create a custom constructor, that default one is obliterated and it no longer exists. So it's not going to create it by default anymore. It's not going to be assumed. So if we want both, we actually have to define that default one. So we just say public user, nothing in the parameter list, and nothing in the curly braces. Now you can also use this spot to assign default values. So you could say set name and, say something like no value or whatever you want. But a better place to do that is actually probably up here. You can use default values here. So maybe no value, but that'd be stupid to do for the name. So maybe for the membership, you can default it to bronze, for example. That's just an example, and I'm getting off topic. Basically, you can do whatever you want in that default constructor. You don't have to leave it empty. The only thing that really matters is that there's nothing in that parameter list, and now our code should work. And based off of this, U2 should have a bronze membership. So let's say u2.getName and u2.getMembership. You can see that the name should be null and the membership is bronze. So that is your friendly introduction to constructors. In the next video, we're going to talk about method overriding. Hello everybody, welcome back to your Java object-oriented programming mini-series. In this series, we are talking about all the basics of object-oriented programming. In this one, we're going to be talking about method overriding, which again mentioned in the previous video, this is different than overloading. So if you're looking for overloading, I have a video on that as well. But overriding is basically replacing a method that already exists. So there's a few methods that I recommend you override that already exist on all objects. The most important one I think is string. So when you print an object, you can define what that's going to look like. Let me show you exactly what I mean. Right now we are printing u2 dot some attribute, but let's just print u2 by itself. So let's go ahead and print u, which is this user up here, and then we'll go ahead and print u2 down here, and we'll get rid of all this other stuff. So when we run this, we just get a value describing the memory address and the type of this data. Well, this is not very useful. And when we invoke print line, it's automatically going to convert these to a string. So essentially what's happening is we're invoking toString implicitly. But if we're passing u to some other method that requires a string, we can invoke .toString explicitly as well. But right now, that toString value is not very helpful. So what we want to do is we want to override toString to be a little bit more useful. So let's go ahead and do that inside of the user class. So here's what it's going to look like. We're going to say public string toString. That's the method return, and then the name is toString. And in here we can just return any string we want for now. We'll customize it in a moment. So we'll just say something really important like tacos. And now let's go back to our code. So when we print u and u2, we should get tacos for both of those. Tacos. Now you can see we didn't have to explicitly say anything like public override, although that might be a thing in other languages, so just keep that in mind. So obviously we don't just want it to say tacos, so what's typically going to happen is it's going to print the attributes of the object. So we can just say return name plus maybe a space plus membership. And we need to get those using the getter method. So get name and get membership. There we go. So this will format a string and return that back to this calling code. So we should get, for example, Caleb space silver. So let's run it. And we do get Caleb silver and then null bronze. And that's because we didn't define a name for u2. Now another useful override that you'll probably want to know about is equals. So if you want to compare two objects, they're by default going to compare by address. So what that means is if these have exactly the same values, let's say Caleb and silver, these are still going to be considered different when it comes to comparing them. So instead of just printing both of these objects, I actually want to print if they're equal. So one way to do this is to say u is equal to u2, and I'm just going to get rid of that. I'm also just going to get rid of this hello world. I don't know why I left that in there this whole course. Sorry about that. And when we run this, we're going to get false. And that makes sense. These are being compared by if they're the same object. So what that might look like is if we said u2 is equal to u, well, now these are going to be true. So that's one way to compare, and that's always going to compare by object. But there's another way to compare that you're going to see a lot, and that is dot equals. So you might say u dot equals u2. And let's run this. And this is still going to run as true because by default, dot equals is going to do the same thing as the double equals. So what that means is if we go back to what we originally had, this is still going to be false because these are not the same objects. So basically what I want to do is I want to make it so that when we say u dot equals, we're going to do a different comparison to see if they're equal by value. So, Caleb, Caleb, silver, silver. So let's talk about how to do that. We just go over to our class and we create that method. So we'll say public, and this is going to be a Boolean because it returns true or false, and it's called equals. And this is going to be invoked on one object. So if we take a look back at our calling code, we have u dot equals. So u is going to be the object we think of as the starting point, and then u2 is going to be passed in. So what that means is we need another parameter here of type user, and we'll just call it u2, and we can compare values. So if, I'm just going to build out the structure here, if getName is equal to u2 dot getName, and getMembership is equal to u2.getMembership. So that should be the basic structure. It's a little bit to put on one line, so let's break this out onto 2 lines. Just make it a little bit easier to read. Space this out like that. And we have one issue, getName. Oh, I accidentally put a single equals there. That just needs to be a method. So if all that is true, then we will return true. Otherwise, we're going to return false. So else, return false. So that is how you override equals. And you can define the behavior however you like. Ideally, there's something unique about each object. So, there could be 2 people with the name Caleb, both with a bronze membership. So maybe something like their address or email address, something a little bit more unique would be ideal, but this is a fine example for this case. So let's run this, and just to make sure we're invoking it right, u dot equals u2, run, and we get true. If we went ahead and changed one of these values, so we run it now, and we get false. So that is how you override equals. Now you don't just have to override these methods that already exist on all of the different classes. You can override custom methods that are inherited from parent classes. However, because we haven't talked about inheritance yet, it doesn't really make a whole lot of sense to talk about that. But basically, behind the scenes, what is going on is that user extends the object class, and all objects have some basic things that are included with it, including the toString and dot equals. Now, another best practice I'm just going to throw out there, I'm not actually going to do it because I don't follow best practices, is the hash method. If you are creating the equals method, you'll probably want to override the hash method as well, which I talked about that in another YouTube video if you want to search that. Hey everybody, it's Caleb. In this episode, what we're going to be doing is we're going to be talking about how to work with numerous objects, and this is going to be a good introduction to generic lists as well. So hopefully, if that's new, we'll be able to explain that to you as well. So right now we've been working with objects directly. However, this isn't really a super scalable option because if we're working with, let's say 100 objects, well, does that mean we're going to have 100 variables? And, we might not always be able to write out each variable in our source code because we might not know all that information until later. So if this is coming from a file or user input, well, that's going to make it a little bit more complicated. So instead of just creating user variables like this, it's probably ideal to create a list that can contain numerous users. So because object-oriented programming allows us to create our own types, this is our own data type, we can use generically typed things and just use that as the type. So the most common, if that made no sense, let me explain. The most common example of a generic type is a generic list. So let's talk about how to create a list. So we're going to just create a variable. We'll call it users, plural. And the type of this is actually going to be a list of user. So what we can do is hover over list, and we'll want to import that. But be careful. We want a specific one. We want java.util. And then on the right side, we're going to say new list of user. And then parentheses. So the syntax might be funky if you're new to generic lists. And then there's one other thing. We got an error here. I'm going to explain why in just a second. But basically, the type is list, and then what we want to store in that list, the type of that thing, is in carets. So any user can go in this list, and that's fine. Now on the right-hand side, we don't want to use list. We actually want to use array list. So a little odd, why don't these data types match? And we'll also want to import array list from java.util. So these data types don't match. Come on, import, noob. All right, so these data types don't match because on the left-hand side, we're actually using an interface list, which is a little bit more general. And then on the right-hand side, we're using an implementation array list. So this is a common setup you'll see. However, you can also use array list over here on the left as well. That's fine, but either one should be fine. Oftentimes when you're creating attributes for an object, you'll use an interface on the left-hand side just to be a little bit more general, which gives the consumer of that class a little bit more freedom on what to choose. But in this scenario, we can just go with an array list on the left and an array list on the right, and that'll do us well. So the way we use this list is we just say users dot add, and this is going to take a user. So we can just put you in there. Not you like you, but you, this user. Gosh, I don't want you to get in this users list. And then we can access that user through this list. So let's just go ahead and see how that looks. We'll do a sysout, and we would say users.get, pass in an index of 0 there. That's going to return a user object, you, and then we'll say dot, and then we have all the members for that. So get name. So let's run this, see if I'm crazy or if it's actually going to work. And voila, we get Caleb. So everything seems good. But honestly, how did that help us at all? We started with 2 lines of code and I said that's not going to work. So I just added more lines of code and it does exactly the same thing. Yeah, I get it. So here's what we're going to do. We're going to get rid of these 2 lines. And instead of adding you, the variable, we're going to create a new user inline here, like so. And you can set data just the same way, or you can use a custom constructor so you could pass in the data here. I want to create one that just requires a username Caleb, create constructor user. And here you're going to see the user class. If you've been following along, we've been building along with this. However, if you're just jumping in, you don't have to have all this stuff. You just need an absolute basic class, nothing in it except the name. That's fine if you just want to follow along partway through here. So this is going to take a string and we'll just say set name and pass in that name. We'll call that name. Every time you do that and you don't save, it gives you an error for some reason, but we'll save and it's working now. So that is how we can add a user inline, and we should be able to run this and get the same thing, Caleb. And this will make it a lot easier to add numerous users to this list. So users add. Now we'll add you, the person, in here. And let's go ahead and add another one in here. Sally. So those are all in there, but I'm just getting that first one. So how do we actually display everybody's username? Well, we can actually use a for loop. So you can do this two different ways, I guess. We can use a normal for loop. So we'll talk about that, and then we'll talk about the other way. So for int I is 0, I less than users dot size I plus plus, and then we'll just print the name here. So we'll say users dot get and pass in I, and then dot get name. Running this, we should get everybody's name. We got an error. Oh, I don't know what happened there, but had a little typo. And now when we run this, we get Caleb, you, and Sally. So this is ideal if you need to know that index, but More clean is just a range-based for loop or a for each loop. So for, and then we say the type, so user, just call it u, and it's coming from users. And then we just print the user itself. So sysout u dot get name. That should work fine. And running this, we have the first loop, and then we have that second loop. I obviously prefer the second loop. It's way less typey, a lot less stuff going on. So definitely my preferred way of doing this. So that's just a little bit of experience with generic lists, and we're using a custom type. That's pretty cool. Hello everybody. In this episode, we're going to be talking about static members of a class. Anything static on a class is accessed on that class directly instead of accessing it on an object. So up until this point, we've been creating new users. And, this can apply for pretty much any class. We're just using these examples. But basically, we create a new user, and then we access data on that user object. Well, something that's static, we're going to access it on that capital user directly. So just as an example, you can literally do anything that's static. You can create a variable to store data, or you could create a method that is static. So what I want to do is I just want to create a variable to store some users in. So I'm in my user class. I'm going to scroll up to the top, and up here I'm just going to say public static admins. And the type for this is going to be, we'll just make this a list. So we'll say list of type user, which makes sense, admins. And then we need to import list from java.util. So that should pop up at the top there. And this is just a convenient way to store some users. It's attached to a user class, so we always have it in existence. So now instead of using this users list, and there's nothing wrong with using this list, I'm just illustrating how static data works. We'll just replace this with user.admins. And then we can assign it a new array list. And this also is a good point to call out. This is where using that list for the data members comes in. We're using that list, so then we can use, this is more general, so that means we could use an array list here, or we could use something like a linked list. The actual specific implementation is up to us. That the list is just an interface, or think of it as an abstract data type. So now instead of using users, we can just work with that admins directly. So user.admins.add, and we'll just do that for all of these. All right, so a little bit more typing on the left here, but overall it's not too bad. Same thing here, user.admins.size, user.admins.get, and then user.admins. All right, so I think I got rid of all the errors. We should be able to run this and get the same exact output. Caleb U. Sally, Caleb U. Sally. Hey everybody, welcome back. In this episode, we're gonna be talking about static methods. Now I do recommend, well in general, you can just jump into this course wherever you need. However, I do recommend that you watch the previous episode in this specific situation, because the previous episode we talked about static data members, or basically static variables. But now I want to talk about static methods, but it's going to build on the same principles. Basically though, the crash course is we access data directly on that user class or whatever class we are working with. This is how system.out works. Out is a static data member, so we access it directly on this system class and we don't have to instantiate it. But now, instead of just talking about variables, I want to talk about methods. But before we talk about that, I gotta tell you guys something. There is no better way to create better code than to have a really solid testing system with high test coverage. And there's no better way to do that than to use our sponsor. All right, so here's what we're gonna do. We're going to create a method that is going to do essentially this for us. So we're printing all of the names of the admins in this case. But if we wanted to do that regularly throughout our code, we don't want to have to write out these crazy loops. We just want to call a method and it does it for us. So it's going to be very similar, and I actually really like this one, not this disgusting one up here. So I'm going to take this one and then I'm just going to delete that one because it's trash. All right, so we'll save this and we'll go over to the user class and we're going to create that method right here. So it's going to look like public static. We'll just call it like print admin names or something. And since this is printing stuff, we don't actually have to return anything, so we can just say void. And that should be it. So we'll paste that for loop here. And it's getting this from user.admins. However, because both of these are static, you don't actually have to invoke it on that user class, so we can just delete that. It's just going to assume that implicitly it's talking about a static member here. And you can see that in the highlighting here, which is nice, a nice feature with these IDEs. So I think that's it. Man, I was expecting this to be like a lot more material, but this is probably going to be pretty easy. So now instead of creating a loop or trying to do the output ourselves, all we have to do is say user dot, and then you can see print admin names, save, run this, and we get Caleb, you, and Sally, which are all the names. Wow, that's so simple. So one common use that I use static methods for is if I want a method to read data from a file to get, for example, let's say I had a file of 100 users in a text file. Well, instead of creating a function on its own, I'll often associate that directly with that user and just create it as a static method. And then all it would do is just return a list of users. Hey everybody, in this episode we're going to talk about inheritance in Java object-oriented programming. Now this is a general programming principle, so it's going to apply pretty much to any of the other programming languages that support object-oriented programming. Also, this is something you can just jump in. You don't have to follow along with all of my Java videos. So if you're seeing this and you're like, oh, I don't really know what's going on, no problem. So basically, we have this user class and you can just jump in and create a basic empty class, that's fine. But you can think of a user as pretty general. You know, it doesn't really describe a whole lot. So we might want something a little bit more specific. But, you know, let's say a lot of the same stuff is going to apply for that new thing. So maybe we have a website for students and teachers. You know, maybe it's something like Udemy where you can have an instructor profile or you can just be a student. Well, in that situation, we might want to create a derived class, which is a class that inherits from user. So let's try and do something like that. I'm kind of just going along with this, and we'll fix any issues as we go. So we'll go over here and right click on our project, new class, and let's just go ahead and call this one student finish, public class student. And what we do is we say extends user. We get our first error, implicit super constructor user is undefined. So if you're just jumping in, you created that user class with it being empty, you're probably fine. But basically the reason that's happening is because we created a custom constructor here, which makes that default constructor not be implicitly created. So all we have to do is just say public user like so. All right, now we should have gotten rid of that error. So far, so good, baby. So the way this works is anytime we create a student, it's going to inherit everything from user. You can think of it as a user, just with some extra stuff in it. So let's go ahead and create something specific to just students. We'll just create an attribute. We'll just do something like Boolean verified. So if they've verified their email or phone number in some way, and we will default this to false. And we will create a way to get and set that. So let's go ahead and start this with an underscore, void set verified, Boolean verified, and then we'll just set that to the backing field here. Verified is equal to verified. And we'll do something similar for the getter. So this is going to return Boolean, and this will be get verified. It's not going to take any parameters, and it'll just return underscore verified. All right, that should be good. So let's go ahead and create a student and see what that looks like. So we'll go over in our main method. Ignore all this stuff for a moment. We're going to use some of this later, so I'm going to keep that. And what we'll do is we'll just let's do this up here. We'll push these users down here. So right at the very beginning of our main method, we will say, I'm actually just going to comment this out for a moment. We will say student S is a new student. And then let's go ahead and print out their verified. s.getVerified, run this, and we should get false because that is what we defaulted it to in the class over here. So far so good. But the beautiful thing here is that it has some of the other stuff. So sysout s dot, and you can see we have, oh, that verified shouldn't be visible there, so we need to change that to private. So save, and now we should just see all the stuff inherited. So we have get membership, we have get name, and then we have some of these other things that came with it. So let's try s dot set membership, and we'll set this to gold. So we're able to give this student a membership even though in our student class we didn't define anything for that. Here, I don't know what I'm thinking. We want to put this on the outside, and then we'll do s.get membership here. There we go. So let's go ahead and run this, and we should get false and then gold, which we just set. So that is how inheritance works. The members are automatically inherited when you put extends. Now you may also see implements here, and that is where you can inherit basically from interfaces, which is a little bit different but fairly similar. When you think of this type of inheritance, you can think of it as being something. A student is a user. Now, if you get into interfaces, you can think of it as behaving or embracing something. So a student might implement an interface that describes student behavior. So maybe the ability to register for a course or something like that. I'm not really going to get into a ton of detail, so I don't want to get too distracted. But the main reason I'm calling that out is because you'll see two things in Java, which is extending from classes and implementing interfaces, and they work very similar. Java does not have what's known as multiple inheritance, which you can find in C++, Python. Instead, it uses the ability to inherit from one class, so it can only have one parent, but you can also implement numerous interfaces to basically give a similar capability. One other thing I wanted to mention before we go is when it comes to method overriding, you can do that for custom classes as well. Just like we overrode equals methods in our user class, you can override things defined in the user class inside of the student class. So you can look into that as you build out more complex classes, and basically you can have this inheritance hierarchy where children are overriding methods defined in the class immediately above it, or from classes a few tiers up. Hey, what's up, nerds? In this episode, we're going to be talking about polymorphism. This is that third pillar of object-oriented programming, and it describes the ability to treat numerous derived classes as their parent class. So in this example, we have a student that extends user. Well, you can just treat a student as a user, and if you had other types of users, you can basically treat them all the same as users. But the magic here is that the students are going to do things that are specific to students, and the other types will do things specific to those types. So that's a lot of explanation and not a whole lot of code and examples. So what we're going to do is we're going to take that garbage and we're going to turn that into an example right here. Now, before you do this, there's a couple things. I would recommend you watch the video about inheritance, which we talked about earlier on in the series, just so you understand how that works. But if you get a general idea, you should be able to survive this video just fine. So in order to best see polymorphism, you need a base class, which we have here, user. I'll just show you that real quick. You don't have to have everything in here, but basically this is going to have some attributes, name and membership with getters and setters. And in our main method, we are working with those things that are a little bit more general on the user object. So we have the membership here, which is defined from that parent class user, defined right here. It's not defined in that student class, but it still works. So that's the first thing. We need to have some kind of inheritance hierarchy. The other thing is that we need to have not only a linear hierarchy, but we need to have a split at some point where we have multiple things inheriting from one base class. So here we have a student inheriting from a user. Let's go ahead and create another class that inherits from user. So we'll just go over here, hit new class, and we'll just call this teacher. And you know, teachers, users, they have a lot in common. They're both people. They both, if this is a website, they both probably have an account, and they both probably need to get verified. But you know, maybe a student only needs to verify their email because it's a pretty simple process to sign up. But a teacher has to go through a little bit more work. You know, maybe they have to verify their phone number, which is a little bit more intimate, you know? So here's what we can do. We can take from the student this verified junk. We can just take all of this, and we're going to put that in the base class user. So I'm going to paste that right here. Like so. So now we'll just make sure everything is working. Let's save everything and just make sure we don't have any errors. And when we do this, we should be able to check to see that they're not verified because it's false by default, and we can set their membership and everything's still working good. And we still get false gold. So I didn't break anything yet. And for that teacher, we're going to do the same exact thing. So for the teacher, we're going to say extends user. So we should be able to create a teacher object along with the student. So we'll say teacher, we'll just name it T, and it's a new teacher. And we can also print out the teacher's membership. So we'll say t.getMembership. So we can see that teacher is a bronze member. But the cool thing here is we can treat the student and the teacher as the same type. So we can even add them to a generic list of the same type. So we can create a generic list. I have this one down here defined in the user class. And I'll show you what that looks like real quick. We just created this list here, new array list of type user. But we should be able to say user.admins.add, and we should be able to add an S, and we should be able to say user.admins.add and pass in T. Since these are both considered users, it's totally fine to add them to an array list of type user. And let's go ahead and give these guys some names. So we'll say s.setName. We'll just say student. And t.setName teacher. So now when we iterate through this entire list, we should get student, teacher, and then Caleb U. Sally. Student, teacher, Caleb U. Sally. All right, so far so good. We're not really seeing a whole lot of benefit here. Let me show you where that benefit comes in. We can basically do an override in student and teacher, and that'll be specific to those base classes. So we'll just create a method to verify the teacher. So that's going to look like void verify, and this is going to invoke that set verified in the base class. So we'll say set verified, and what are we going to pass in here? Well, we're going to pass in the Boolean value true, but we're also going to do just a little print line here. And this is basically where you would fill in the verification process, you know, if you needed to send them a text message and get that back or whatever. But we'll just type out verifying through phone. So I'm going to copy this. It's going to be very similar for the student. So we'll just, oh, I'm hungry. I'm just going to paste that in here and verifying through email. So they're just slightly different. And just so this is overriding something from the base class, I'm going to put that in here as well, but just keep it very general, verifying. There we go. All right, so what we can do now is we'll go through this and we will verify all of the different admins. So here, instead of printing all of the names, what we're going to do is we're just going to iterate through that list. So we'll create a custom loop for user U coming from user.admins. What are we going to do exactly? We are going to verify them. So u.verify, we see that as an option here on type user. And let's run this, see how many errors we got. All right, let's check out this output. It's interesting. So even though these are all users, and inside of that user class, we defined it to just say verifying ... The ones for the students specific say verifying through email. The ones for the teacher specific say verifying through phone. And then if we're just working with general user objects, it just says verifying ... So looking pretty good. if you just need a little silly example to understand what's going on, imagine you had a bunch of pets. You had dogs, you had cats, you had alligators, and ferrets, right? And they got to go to the bathroom, so you say, hey, pets, go outside. Well, the alligator might go over to your little pond, and that's where they go potty, and your dog might go over to the bushes. They all do their own thing based on what they are designed to do. However, they all have that same thing in common, the ability to go outside to use the bathroom. And that would be defined in a base class pet. Okay, so that example was totally dumb. So let's get back to what we were talking about, which is dealing with users. There's one last thing I wanted to talk about in this episode, and that is, well, what exactly is a user? Because, we have students, we have teachers, but what's a general user? What are these three anyways? Well, in my opinion, a user that's not defined as a student or a teacher shouldn't be able to exist. They should be one or the other, or possibly build functionality for both. So you can think of this base class as being an abstract concept and not so much a concrete example, whereas a student and a teacher is a more concrete example. So to do that, there's this keyword we can use. So if we go to user, scroll up to the top here, we can define this as abstract. It's not actually a thing. We save that. We don't get any errors on user, student, or teacher, but we're going to have errors inside of this code because we're instantiating users, which we can't do. So we need to decide whether they are students or teachers. Now, I didn't really design this example to be a student and a teacher, but my bad. We're just going to go with what we got. So we'll just replace new user with something more specific, such as teacher. And maybe this one's going to be, oh, that's not liking that. Oh, I didn't define the constructor for it to take just a string. But you guys get the point. Basically, we can create students and we can create teachers, but we can't create users. All right, so that's all I got for polymorphism. It's one of those things that's a little bit more complex to explain and come up with some really good examples. So I did my best and hopefully it is helpful. Basically, when you need to be able to address a large variety of types all as one general type, you can do that using polymorphism. If you've enjoyed this content, please be sure to like, subscribe, share it with your friends. If you just share this with one person trying to learn to program, I think it could really help them out and it would tremendously help my channel. If you want to see more, let me know what you'd like to see. Maybe we can do some more object-oriented programming stuff. There's definitely more we could talk about. And just as a final reminder, just for those who didn't see the first episode, we do have a course out there that I created. Again, I don't really make a ton of money off of it. It's just something that you can go watch with a free account and get a little bit more depth in Java object-oriented programming.